Hi there, guys. We're going to take our notes today on the scientific method. This can be found on packet pages 7 and 8. Throughout these notes that I'm going to give you today, you can pause me. This is the only chance you're going to get to make me be quiet whenever you want by just using the pause button on your screen. So anytime I give video notes, I will encourage you to, if you need to hear something again, you can go ahead and rewind. If I'm going too fast for you, you can pause me and I'll stop talking and then hit play again whenever you're ready. So if you need to get out your packet and get it opened up to pages 7 and 8, you can go ahead and pause me while you do that. Otherwise, you can just keep going. All right, so the scientific method is a set of steps used to find answers to questions through experimentation. Now, if you look on your packet, right there, see where my spooky finger is pointing on page 7? You're just going to fill in the blanks. So I'm going to go ahead and go back to that slide again. And you can fill in the words where the underlined spots are. Go ahead and pause me if you need to while you fill them in. All right, the next thing we're going to do is fill in the 6 steps in the flowchart at the top. You can see there's 6 boxes where my spooky finger is pointing, and there's arrows from one box to the next box in the correct order. So that's where you're going to fill those in. So the first step is the scientific question, also known as the problem. Step 2 is research. Step 3 is hypothesis. Step 4 is procedure. Step 5 is collect data and analyze your results. And step 6 is your conclusion. And again, you can pause me if you need to catch up and fill these in. So you should be filling in the little flow chart, the 6 blocks at the top of page 7. Now, the next thing we're going to do is start to fill in a little bit of information about each step. So we're going to go ahead and write step 1, right where my finger is pointing to step 1. So you're just going to write in that spot scientific question or the problem. Now, underneath that, where it says number 1, there's another fill in the blank. So these are pretty simple notes to do. We're just mostly filling in blanks. So you'll be stating the scientific question. It must be able to be answered through an experiment. You need to make sure that the question or the problem is something that can actually be answered through an experiment. For example, a good experiment would be something maybe like, what is the best liquid to water plants with? In an experiment like that, you could water different plants with different liquids and see which one grew. You could measure the growth, or you could find out how long it took for them to turn brown and die. A bad experiment example, a bad question would be, what's the best ice cream flavor? There's really not an answer to that because everyone's going to think it's something different. Personally, I think it's the Turkey Hill Double Dunk. However, you might not like chocolate, or maybe you don't like cookies. So your favorite ice cream flavor might be strawberry or vanilla, or maybe something completely different. So that one is really not a question. It's not a scientific question because you cannot do an actual experiment to find out the answer. Now, step 2 is research. So right underneath where you just filled in at the bottom of page 7, you'll see where it says step 2 in a blank. Fill in the word research there. Then just fill in the 2 blanks. Research is to collect information. Research can be done in a variety of ways. I'm sure you've all been to the library at some point. There's a lot of books there, and some of the books are actually true books. They're nonfiction. So you can always go to the library and find a book about the topic. The internet is very popular for research. just make sure if you're using the internet, you're using actual legitimate websites. Anyone can invent a .com website. I could make up thebesticecream.com, and I could write all of the information I wanted, made up of course, about how Turkey Hill Double Dunk is the best ice cream on earth. That's not a legitimate website for research. Government-run websites and university or other educational run websites, are good websites, and you can get a lot of good information. Another hint is to see if you can find that information in more than one place. If you can only find the information on one random website, it may not be true. Scientists are always testing each other's experiments and hypotheses to see if what the other scientists did is accurate. So in order for something to be good research, you should be able to find the same information in multiple different places. Another good thing to research would be by interviewing someone. You could interview a scientist, you could interview someone who has a job related to what your experiment is about. There's always watching TV shows, documentaries, things like that to help you get research. So there's a lot of different ways to research. The easiest is probably using the internet, but don't always limit yourself to just that. Textbooks are another great place to find information. Your science textbooks that I keep in the room, you can always look in for research. You have a social studies textbook. Throughout your life, you'll get lots of different textbooks. All right, step 3. So now we are flipping over to page 8. Step 3 is the hypothesis. So you're going to form a hypothesis, which is a possible answer to a scientific question. When you write a hypothesis, you want to be basically guessing what the outcome is going to be. I think that watering the plants with orange juice will cause them to die. So I told you what I was doing, and I told you what the outcome was that I thought would happen. You can't just say, I think the plants will die, because now I don't know what you're doing to the plants. So you want to be specific in your hypothesis without being overly specific. But you do want to make sure that you are telling me what you think the outcome will be. And you always want to make sure the outcome is related to the actual experiment. A good way to write a hypothesis is by saying, if ... then ... If the plant is watered with orange juice, then the plant will die after several days. So using that if-then formula is a great way to make sure you have the correct information you need in a hypothesis. This formula doesn't work for every experiment, but for most of them, it will apply. And it's a really good way to check that your hypothesis is a good one. Step 4 is your procedure. So you're going to test your hypothesis, which is carrying out the experiment, sorry. This is where the fun part comes in. A lot of people don't enjoy the research. The hypothesis it's kind of fun to make a guess, but it's not overly thrilling. The procedure is the fun part. That's where you get to do the hands-on science and use the lab equipment and go to the table and do all that fun stuff. So you want to record the procedure, which is the steps followed during the experiment. In most cases in this class, I will hand you the procedure that's already written. But there might be times where I ask you to write the procedure, and you would need to make sure that it's steps that can be easily repeated by another student or another scientist so that they do the exact same experiment that you do. Part of the procedure is the materials. So you always want to record or have a list of materials. Again, when we do a lab activity in this class, I will almost always give you the procedure with the materials already written on it. A procedure is almost like writing a recipe or reading a recipe. When you have a recipe, if you've ever cooked or baked, you probably had a list of ingredients, and that would be the materials. and it told you the amounts and everything you needed. That way you could get everything gathered up before you start, so you're not running through the kitchen trying to find everything while something's burning on the stove. And then a recipe will have a list of procedures. It'll have steps to make that recipe. It'll tell you what to do in what order, when to add this, when to mix that. It might give you a temperature to heat something on. It might give you an amount of time that something should happen. So it's very similar to cooking. Step 5 then is to collect your data and analyze your results. The data collection actually happens throughout the experiment. Oftentimes you'll be doing part of an experiment, you'll stop, you'll write down some data on a data table, and then you'll continue the next portion of the experiment. So the data collecting doesn't always happen at the very end, although sometimes it does. So continuing to fill this in, record data, which is information and observations gathered through the experiment. Most of the time there will be very specific data that I'm looking for. Maybe it's an amount of time, maybe it's the mass of something, maybe it's a temperature. So you wouldn't be writing down every single observation that has nothing to do with the results. And we'll normally have a data table to write our data on. And another part of this is analyzing the results. So you want to look at your data and get it organized. Figure out what it means. Finally, your conclusion. Step 6. So you're going to look at that data and you're going to draw a conclusion, which is the answer to your scientific question. A lot of times your data might be in a graph or a table format, because graphs can often help you to see a trend or a pattern in your data. Often the hardest part of doing a lab experiment is the conclusion, is seeing if you really understand what that data is telling you. And that's the part that you really have to stop and think, and you can't rush through just to get it finished. All right, so at this point, your notes should be completed. So you're going to just take a look back and make sure you have filled in all the boxes and all of the blanks on packet pages 6 and 7. And I need you to, once you're finished here, take your packet or raise your hand and have Mrs. Smith double check that your packet is completed. And then she will tell you what to do next. If you need any of this information again, you can watch this video again, or you can just rewind it to whatever part you missed or maybe a part you don't understand. If you have questions, please ask, and I am here to help you. Thanks for watching.